You are welcome to Toide online class. So today I want to introduce indices. 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 So why do we have the concept indices? Of course, we know that the use of powers provides a convenient form of algebraic shorthand. That is, in mathematics, right from GSS class, we know that we can have something like x times x times x times x. If we have x in four places. So how do we compress this so that we can have algebraic shorthand? That is, we can reduce it. Of course, we are taught that this is x raised to power 4. That is, this is x raised to power 1, 2, 3, 4. So it will be the abbreviation of this is x raised to power 4. So the use of power, this power, the use of power provides a convenient form of algebraic shorthand. That is, we are able to write all this story, all this one, we are able to write it in this form. You understand? So where we now have x raised to power 4, this x is referred to as the base, is the base, where and whereas this 4 is you can call it either power, it can be referred to as power, or you can call it index, or you can call it exponent. So you can use any of these three words interchangeably. That is x raised to power 4. This 4 can be referred to as power, it can be referred to as index, or it can be referred to as exponent. And of course, the plural of index is indices. So the topic is indices. Indices. So for us to be able to perform operations on indices successfully, there are some laws, that we call it laws or rules of indices. So for us to be able to perform operations on indices, we must take note of the laws of indices. Laws of indices. Laws of indices. The first law says that if you have x raised to power m times x raised to power n, look at it very well. The base must be equal xx. Then the power can be the same or differs. And if the operating sign here is multiplication, the law says that you are going to have x raised to power m plus n. If the operating sign here is multiplication, the law says that you add the power together. That is the first law. E.g., when you have 10 raised to power 2 times 10 raised to power 4, if you are to apply, if you want to do this, now, no, of course, you know this one is 100 and this is 10,000. How do you multiply this without calculator? But if you just want to get the answer in a shorter form, then just say this is the same thing as 10 raised to power 2 plus 4. And that gives us 10 raised to power 6. And of course, we know that 10 raised to power 6 is 1 million. So this, with this law of indices now, we'll be able to solve this type of problem at very short interval. Then the second law says that if you have x raised to power m divided by x raised to power n, then the law says that it's going to give us x raised to power m minus n. Please, I want you to note something. When we have the operation multiplication, the law says that you had the power. Now that we now have division, then the law says that we subtract the power from each other. E.g., when you have 10 raised to power 4 divided by 10 raised to power 2, what do I get here? If you apply the second law, I'm going to get 10 raised to power 4 minus 2, and that is 10 raised to power 2, which is equal to 100. And that is what we are going to get. Then the third law states that if you have x raised to power m all into bracket n, the law says that this will be x raised to power m times n. That is, e.g., if we have 2 raised to power 3, everything raised to power 4. What do we get here? That will be 2 raised to power 3 multiplied by 4, and that will be 2 raised to power 12. That is what we are going to get. And that is that about the third law. That third law. Then we move to the fourth law. The fourth law says that x raised to power 0 is equal to 1. That is, e.g., this law is telling us that anything raised to power 0 is 1. E.g., 100 raised to power 0 is 1. If you have 25 raised to power 0, it's 1. So anything raised to power 0 will give us 1, and that is the fourth law. Then the fifth law says that we can have s raised to power minus m. That is, if you have the index or the power or the exponent to be negative, how do we express it in positive form? Then this is what we are going to do. We'll write this as a reciprocal in order to eradicate this negative. Then this same thing as 1 all over s raised power m. That is, this is the positive form of writing this, and this is the negative form of writing this. E.g., when you have 2 raised to power minus 3, how do you get this? Just say this is 1 all over 2 raised to power 3. And that's going to give us 1 all over 2 in 3 places. 2 times 2 times 2. And that is 8, 1 all over 8. And that is what you get. Then the sixth law. The sixth law is when you have either square root, cube root, quart root, or what have you, or generally nth root. The law says that when you have s raised by 1 all over m, that is same thing as you saying you are finding the mth root of x. That is, e.g., let me give example. When you have 27 raised by 1 all over 3, this is the same thing as you saying you get finding the cube root of 27. And of course, the cube root of 27 is given as what? As 3. The cube root of 23 is given as 3. Or, so that is what you get. Then let's just talk about the last law that I have here. When you have s raised by m divided by n, this is given as nth root of s raised by m. E.g., when you have 4 raised to power 3 all over 2, you realize that the exponent in this case now is fractional, where the numerator is m and the denominator is n. The denominator is talking about either nth root, like either square root, cube root, quart root, or nth root. Why the numerator is talking about square, cube, quart. So that is, in this case now, this is what you get. We are going to have, in this case now, we are going to have the square root of 4 raised to power 3. This is what we get. Of course, the square, the 2 will be here, but it's not necessary. It's not compulsory we put it there. So this is what we are going to have. So if we have this, at the end of the day, we are going to have this to be square root of 64. So this is what we are going to get. 4 raised to power 3. 4 times 4 is 16. 16 times 4 is 64. 64. Then the square root of 64 is equal to 8. And of course, or if you don't want to do it this way, of course, when we have 4 raised to power 3 all over 2, we can express 4 as index of 2. We can change 4 to 2 raised to power 2, multiply by 3 all over 2. This can take care of this. Then at the end of the day, we have 2 raised to power 3, which is equal to 8. I just want to establish here that I will not compel you to be rigid with this law. Of course, mathematics, as a mathematician, we need to be flexible. We can approach same problem with different approaches, provided you did not perform any magic. If your answer should come out naturally, then go ahead and do what you were given. So I want to take examples. Let's say example 1. Simplify the following. That is, let's give example and let's apply some of the laws that we have considered for today. Then there's another one, 125 minus 2 over 3. Then let's take one more question in this section. And of course, we can go ahead and do some other thing. 2 raised to power s raised to power half multiplied by 3 raised to power s raised to power minus 5 all over 2. Okay, this example 1 now. Let's solve these 3 questions. The first question says that 27 raised to power 1 over 3. That is, this is asking us to find the cube root of 27. So the cube root of 27, of course, will be 3. Or, as I've said earlier on, we don't need to be rigid with the laws. I can say 27 raised to power 1 over 3. Can I express 27 as an index of another digit? Yes. This same thing as 3 raised to power 3. 3 in 3 places is 27. So if I have that now, multiplied by 1 over 3, this can take care of this. At the end of the day, I will have 3 raised to power 1, which is equal to 3. So the second example is where you have 125 minus 2 all over 3. Of course, whenever you have problems under indices, look at the denominator. In this second example now, the denominator is 3. Then this 125, can I express 125 as an index of a particular digit. Yes.